if there's a laptop next to us, and or if there's two computers that we're using, and we've got the tool running on one of them where they can see us throughout, but will it be a breach if there's a laptop and then you're accessing Excel and doing
No,
calculations on a separate
no,
screen? Okay,
no, that's
okay,
fine.
that's fine. Okay,
That's
okay.
fine. It's different with the other with some of the other what other tools that they try to track you. But this one is specifically set up because what happened in the past is that, say, the four of you that are online now was sitting in the same room
Mm,
and and doing
mm,
the exam together. So that is just actually what
okay.
it wants to to
Oh,
eliminate. Um,
cool.
so it picks up that so it's specifically, and that's why at some stage during the year you needed to load your um, a photo of yourself somewhere on a system.
Oh,
Um,
okay.
and if it wasn't this year, it would have even been last year. Um, but that is basically so they just the whole time just looking to see that it's actually you doing the work.
Okay. Okay.
So that, and that's why be, because you can't, I say you can't have another device because I have my HP 10
Mhm.
is somewhere in the house, but I have it downloaded on my PC as well. Um, so what it possibly can also see is what other windows are open. But again, I have my study document is in PDF. I haven't, and I don't know if any of you actually have received a printed copy. So so that's why they're using this one rather than the other more
Mm.
technical tools.
I just,
So I think somebody said about the so how it- how your assignments was nearly how you would that is the tool that will be used for your exam as well. So you might not even be aware that they in the assignments used and checked that it was you that was doing it.
oh, okay.
So they've been trying out this tool now for a while, and I think in the end, all of the my unis or all of the things will go to this platform and leave the other
Mm.
tools out of it. So I think that is where it will go in the end.
Okay, cool. So this new tool is also going to monitor your whatever screens, multiple screens you've got open, just to confirm that you're not using WhatsApp or a Telegram online.
Precisely,
Yeah. Okay.
precisely. And that's why the lecturer said he doesn't he doesn't know if it can pick up what other screen you're using.
Mm.
So that's nearly so rather than use if you have a different device,
Mhm.
um, a different device then always. But he's still going to find out because I asked him about. But
Mm.
if you have now PDF as your study guide open, will that pick it up as a different screen? And he was like, he also doesn't know. So he's like,
Mm.
you will find out for us.
Cool. Good, good.
Okay,
Thanks, man.
cool. Let's go. So so we're just going to continue today. We're starting with the normal distribution, all the distribution functions. Um, so, and I hope you can see my screen.
Yeah, chapter.
Cool. Okay. So in this one again, we see a very um, definition type of question. It and what is interesting about this is it asks the finer details of your normal distribution. So it's not things that we always use, like option E. But let's see. Okay, so all we're looking for incorrect. The z-score of a mean of a normal distribution is 1. Okay, true or false?
That sounds true because of probability, right?
The z-score.
Oh,
See, so look at the structure of the question. The z-score of a mean of a normal probability distribution is 1. Okay, incorrect. Look at your, uh, and if you just look at your z table, you see on the z table it goes from -3 to 3, but you can even go higher. So then it caught you out now because you were thinking about the
probability.
probability under the curve will always be 1.
True.
And so that is very important, the sentence structure. So they actually it's referring to the z-score and not at all to anything about the probability in that. Okay, so very careful when you read this these types of questions, because they are there to nearly confuse you, because if you said that one is correct, then somewhere else you would, and that's an easy one to get wrong. Um, the smaller the value of a standard deviation, the narrower and steeper the curve. Okay, so what this means is if a normal distribution is like the standard deviation is large, we get a larger spread. If it is smaller, it will be something like that. So depending on how big the standard deviation is, the bigger, nearly the flatter the curve becomes. The steeper or the narrower, the steeper it becomes. So you can nearly see it in that way. So if my standard deviation is, say, 20, that's still a normal distribution. So if that was a standard deviation, if my standard deviation is 10, probably do something. But if it was 5, it will do something like that. And all will still have the same mean. The rest will just be a bit different. So your mean, median, and mode will all still be the same for all three of them, but your standard deviation will be different. Okay, so but I think that is also somewhere in the book. There's a definition of that. The mean of a normal distribution can be any numerical value. Example, negative, 0, or positive. That is true. So the mean can be, it all depends on what we're looking at. So so if we look at kg or the kilograms of people, we need to probably always positive. If we look at um, the mean temperature of a place like Sutherland, um, you know that the temperature can go into the negative. So it basically looks again at your continuous variables and things like that that we did in study. Phew, what was it, unit 1 or 2? Um, so it can definitely be um, yeah. Okay, so let's just see the next one. The area to the right of the mean and the area left of a mean is also, so that's also correct. So that is, remember when I said it's symmetric, that side is 0.5, this side is 0.5. So that's just what it nearly tells in words. Then in somewhere in our there's a table of one standard deviation. There's 1, 2, and 3 um, standard deviations of a mean that we talk about. The second one is the 95 one. I think the third one is close to what we always say, the 99 one, but it's something like 98 point. And the first one is normally closer to I think there's 64 or 65 or something like that, but I'm not 100% sure. But that's also, I'll check if I can get a page reference, but that is definitely straight out of your textbook and your study guide as well. So we know two standard deviations of a mean is 95.4. Um, I'll definitely get you a page reference for most of these, because this is purely out of a textbook and out of the study guide. Okay, so let's go into the meaty stuff of standard deviations, and you'll see, I nearly want to flag this as as something that you will get in the exam, um, because this tests a lot of the things that you need to know. Um, so it is testing that you know how to use the Z table. It tests how you need to look at the Z table. So this is really one of the important ones. It doesn't ask you to work out the Z table or the Z value, but that will be somewhere else in a different question. So we need the Z table for this. Okay, so let's first see. Okay, so, and as always, I'm drawing this. It might be a bit small, but just to get all of them in. Z bigger or smaller than minus 2.8. Okay, so there's minus 2.8. That's 1, so we know at least that one is 0.5 at whole size. But they want us to get the bigger area. When they say that is equal to When I say that is equal to when I say that is equal to 1 minus, so we'll get to the minus now, bigger than 2.8. So if it was bigger than 2.8, it's that side. If we say 1 minus, we're doing that. Okay, so out of a symmetry, we know that even if it doesn't look like symmetry on that, we know that that, if it's 2.8, is the same size as the minus 2.8. So that is out of the rules of normal distribution. So in both of them, we're looking at the other side. So this is correct. So if we said, okay, I want to get that blue side, it is exactly the same size as if I said I wanted to get the green. Okay, so every time we're just leaving out that area which are the same. Okay, so for the first one, that is spot on. It is correct. Okay, so here we're testing very interesting in the first two, more the symmetry than actually going to the Z table. You could have gone to the Z table and got the values as well. And you can go and test this yourself nearly if you get the same answer, which you're supposed to get. Okay, let's look at this one. Smaller or equal to minus 1 of 2.1. Okay, so that area, is that area equal to probability bigger or equal to 2.1? Okay, so basically again, the symmetry, so that and that part will be equal. So that is also correct. Okay, so the first two, they're basically asking you about that link back to that symmetry of what we've seen in the previous question. Now it becomes a bit different. So now they're asking us, luckily with the same numbers. So if you were working out those numbers, at least we're working with the same number set. So it's not that you need to, it might have that you already have been calculated some of those numbers in question 1 and 2. So again, if you're more comfortable in actually working out the numbers, do it that way, because I would in any case now need to go to a table to to get those numbers. So let's look at the next one. Z equal to minus 2.8, smaller than 0. Okay, so I need to calculate that space. So if I in option 1 had that, I could have done it now. So remember, this is 0.5. So what we now need to do is to say, okay, what is left here in the green area is also 0.5. So it's going to be 0.5 minus whatever is in the purple area. Okay, so I think that is just important for this instance, because we normally want to say 1 minus, but because it is up until 0, we're not doing the whole one, we're only looking at half of it. Okay, so then we need to go to the minus 2.8. You could see I used it before, 0.0026. So that small area was 0.0026. Which will then give us 0.4974, which is correct. Sure, okay. So in the exam, this would have been a long process. Okay, let's look at, and there's really none that one could just eliminate, which is also not cool. So 0. So they're basically asking us what is this area between 0.8 or minus 2.8 and 2.1. So they're asking us that area. So easiest for me is to say 1 minus that. We have it already, 0.0026. So now if you calculated that, which was 0.0179, we just could have used it already. So, and then minus, we just subtract that side, 0.0179. That answer, let me check. Is something like 0.9795. Okay, which is correct. So the last one is then the incorrect one, but let's see if we have some space. I'm going to do it in this area. There's some space. We're checking out smaller or equal to 2.1. So we know that that area is already 0.0179 and bigger than 0. Okay, so we're looking for that area. So it is again 0.5 minus 0.0017, 0.017. See, it's early in the morning. I need another 2 cups of coffee before I'm awake. Definitely more coffee. Okay, that will give you something like 0.4821. Okay, so just on the second decimal that was wrong, but that is then your answer. Let me just do that. Okay, so Phew, this was a hectic one. There isn't really any shortcuts with that I can see. Lynn, yes.
Hi, John. Sorry, I'll be quick. Option D. I also didn't have coffee this morning. I'm a little bit lost with D as to the method as to how you use the 1 minus the 0.026 and the 0.179. I just
Okay.
didn't get the graph yet, please.
Okay, cool. So you're fine with how I got that one, but not that one.
Yeah. It's just where, yeah, subtracting
Okay.
it to satisfy the interval.
Okay, cool.
Yeah,
So
yeah.
let's,
Yeah.
and I think that is, let's quickly do this. See, check out of just a blank. Okay. Nope. Okay, so that was your graph. I think that was the minus 2.8. That was the 2.1. So they ask us to work out that area. We need that probability. We know the total probability is 1. Okay, so we've seen that for the minus 2.8, it was 0.0026. So I already, for that, I can say minus 0.0026. In option B, we worked out that that size is just as big as that size. Okay, because that is what this is telling us. So if that is 0.0179, that is also 0.0179. Okay, so then if I need to get rid of that part, so that is why I say, okay, I need to minus that by 0.0179. Okay, and then I will get this total. Okay, does that make...
Yeah, okay, cool. So I basically took the complete one, which is the entire area, and subtracted the two small portions on the left and right.
Yes,
Okay,
yes,
understand. Thank you very much.
yes.
Thank you.
Okay, any other questions on this one? Yeah, this one was, shoo, this was a rough one because this takes up tremendous lot of time. It's and luckily we're working with the same two number sets throughout, but this really took up a lot of time. So hopefully something like this is actually not in the exam because it is time consuming. And there wasn't anything that there wasn't anything that you can write straight out say it's not correct, which is even worse. So that, yeah, I think that was quite a difficult one. Okay, let's move into the next one. Just moving some stuff on my side. Okay, given that Z is a standard normal distribution, what is the value of Z such that the area to the right of Z is that? And I think you guys would have gotten something like this in the exam or in the tests as well. It does creep up in the exam. It's not very every time. So that's why I say it creeps in sometimes, because now it nearly tests for opposite. So they tell us the value. So you need to basically find the Z value of the area right to the Z. So remember, right is that side. So we need to get the Z where this area is 0,2061. Okay. Remember, Z is there 0, to this side positive, to that side negative. Okay, so very important, because we know it's going to be a positive Z. Eliminate, eliminate. Or automatically you can say, well, with two negatives I can take out. Because if I'm working in that area, that is where it should be. It must be positive. Then, how I would have looked at it in my exam is say, well, if you give me that and that as negatives, then it's probably one of those two is the answer. Don't know yet, but let's find out. So we want to get the area where that is 0,2061. So if I know that is 0,2061, what is this area?
So
1 minus, I say 2061. Okay, so let's do that. 1 minus 0.2061, 0,7939. Okay, so now we can go to that positive Z table and look for 0.7939. So let's go, where's the positive? So in here, we now need to get to that 0.7939. You can see I've used it before, but how I would go by it is I would check for a number that I normally work with is a 1.6, and I say, okay, let's go down. Let's see, okay, so there's 0.7939, and the Z that goes with it is 0.8, 0.82. Okay, 0.82, so that is the correct one. What you will see is if you used the negative table and you said 0,2061, there is minus 0,02 or 0,82. So if you used the negative, because if you maybe set it's on that side, you would have then set option D, because you would have gotten to that answer. So again, just be careful for wrong answers. There is actually sometimes a wrong answer to pick as well. So just be careful. It's sometimes easy to say, okay, you work and you go automatically to that side instead of reading to the right. And so what will happen now in the exam, if you get a question like this will now be randomized between 2 or 3 options. So it might be that in the exam they say left for some of you, right for the others of you. And then we do exactly the same. You then would look at that area, and then you will go to the negative table and your answer would have been minus 0.82. So just be careful in the exam. That is where it's on those things that the exam papers would differ between. I think there's 3 or 4 versions of the paper. So it will be on those things that it will be different, and maybe the 0.2061 that it could get to the minus 0.58, but it will not differ in questions. Okay, so this was one of those ones that I think you also might have gotten in this year's papers or assignments. Consider normal random distribution with a mean. So we've got the mean. So let's just remember how this looks like. Okay, so we know the mean, 300. And the standard deviation of 1,800. Calculate the probability that the random variable is at most. Sure. At most, here we come in again, at most. Okay, so do this automatically, then I remember it. So at most, so then we know 3,800. So 3,800 minus that. So 3,800 minus 3,000 divided by 1,800. So what is the probability that Z is at most 0.4444? Yo, it'll be interesting to see if that is going to be on a table or we need to. So 0, okay, and let's at most. So let's see. So the Z is 0.4444. Remember that point in the middle is always 0, so it is somewhere to this side. So we need to work out that size of a probability. Okay, if it was there, remember that is 0.5. So this will be something that is bigger than 0.5. Okay, all 3 of them eliminated already because they are less than 0.5. Okay, so remember, if I draw the Z table, my probability in there is that part is already bigger than 0.5. So the small part that I will add will be giving it more than 0.5. So all the others I could actually take out. Okay, so let's quickly look at the table. Hopefully there's a 0 point positive table. Okay, so we now look at with Z. So this we need to round off because we're not. So Z will be equal to 0.44. We're not going to have so 0.44, 0.44. Okay. It is 0.6700, 6700. Okay, so there already I should have said we're gonna look for 0.44. That would have made it just a bit easier as well. But because positive, it will be on the right hand side of the zero. So that's why those three you can already cancel out. Does that make sense? It's taking a lot of the previous work and putting it into a way for you guys just to eliminate options. Yes, Lynn.
Sorry, John, is there a rule or a guideline as to when we use the positive and negative table? I think you mentioned something about that just now. When to look up.
There's
Yeah?
see so I my guideline. um, so if I and let's say that is the middle. If I need to get that, I use the negative table because that already say it will be say minus 2.25. Then it's easy to use the negative table because that is what it gives me. If I need to work out that area, and let's say that was like we did in our one, 2.1. Me personally would also use the negative table for this because of the symmetry. I can go to negative 2.1. I get the area of that, and that must be then the same as the positive 2.1. But I know it's for other students, it is much easier to say, let's go to the positive table. We work out this area because that is also that's available on the positive table. We look at where 2.1 is. It's 0.9821. We say 1 minus 0, what was it, 9821. And you will get exactly the same answer as that. So for me, it is, you need to be with which one you're comfortable with. If I needed to work out that, just that area, then I would have gone to the positive table. And it say now this was 0.45. I would have gone to a positive table and I would have gotten that. But if I need to go into the other side of it, I will go to the negative table. The same if it was asked of me if I needed to work out that. area and say that was 1.6 or minus 1.6. I would have actually gone to the positive table and see what that big area is, because it's going to be the same. But it might be easier for you to say, let's get the value of minus 1.6 out of the negative table. You get that. And when you say 1 minus it, because then it gives you the so nearly for everyone that you need to work out a z value and get a probability, there is two ways for you to work it out, with the positive and the negative table. And it's nearly what you are most comfortable with. That doesn't really answer your question, but that is how I normally look at it. So you have both tables, so it's nearly, as you practice, see which one you were most comfortable in using.
Okay, cool.
Because across the board, you guys will use it differently, because it's just how comfortable you are with using it.
Okay, now, because in the previous question, I think you mentioned that if the question is asking you to the left of Z, does that mean you use the positive table? Yeah, the one before. And if it's the right of Z, then we use the
See,
yeah.
so let's
Yeah.
so here they ask us to the right of it. So here it was nice because that is spot on how a positive table looks like. So that is why I would use the positive table.
Okay. Okay, got it.
If
Okay, same much.
if it was to the left,
Okay.
then again, spot on how the negative table looks like, and I will use that. If it was, and now if a value was still there, so remember here we said when I use for positive 1 minus that area.
Mhm.
If it was this area, and when it was set to the left, then that will reflect just as your positive table is, and you will just read off the number from your positive table. Now you don't need to say that area, yes, okay, it was a negative 1 minus that gives me that. Then you can go straight to your positive table and read that off. So again, it's nearly what and nearly how I want to tell you what works for me is to draw the diagram,
Mhm.
and then whatever they tell you. So if you need to do something in between, then nearly it's for me, okay, we know the whole thing is one. I want that area to be subtracted. I want that area to be subtracted. So I'm looking for those two numbers. Then it is what's the easiest to get to those two numbers. It could be that they ask you the same thing, and it is where that is 0, and you in both the negative space, where it is, say, minus 2.25 and minus 2.1. And when I ask you that, so then what would you do if you get that type of question? So when it is a bit different, so then for that, I would have said, okay, what is my total area of that? And then I would have just said minus that smaller area. Then I would have gotten that
Mm.
small piece. So it all depends on nearly what you need to get, and that's why I I can't do these things without nearly drawing it for myself and
Mm.
visually seeing what to do. Um, but that's just how I, out of practice over the last few years, it's just easier with these things to visually see it because one gets extremely confused when you s- and when you see a bunch of things like this because you nearly don't know where to start or where to go to. Um, I think there's more like that, so don't worry. But I'll go through a few more. But I think that is for me. It's nearly always I when it comes to the normal distributions. I just want to draw it out first and see what it actually I need to do. Um, just makes it easier.
Okay, cool. Thanks. Thank you.
Okay, so
Thanks.
so let's go into the next one. Very similar. Um, upon conducting further research prior to the transport, blah 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 blah. Rural schools is normally distributed with a mean of 114. So it looks very similar. Distributed 114 and a standard deviation of 72. What is the probability that learners' travel time from home to school is less than 100? Let's just go back to where was that other table? I just copied in for you here. So where did that now go to? Okay, so they say that is less than. Where did I see that? Less than. Okay, less than, more than, no less than. Oh, this is interesting. At most, at least, no less than. Okay, so yes, actually is less than. So they used exactly the same wording that is in that. So we can already say we're basically looking for that. So where Z is going to be smaller or equal to. Okay, so that is 100 minus 114 divided by 72. So we get minus 0.19. I rounded it off um, because we're going to use the Z table. Okay, so now this one is 0. So The negative is on this side, so let's say minus 0.19. Okay, so we're looking for that area. Okay, first thing is, so that on that side it's 0.5. There is a gap there, so we definitely something smaller than 0.5. So in the exam, smaller than 0.5, smaller than 0.5. So that is bigger, so we're looking for smaller than 0.5. So that doesn't work, that doesn't work, that doesn't work. Okay, in the exam, two options available if you needed to guess A or B, A or D. So only two that you. So if you pressed for time, this is nearly a very easy one to. You might still guess it wrong. But at least if you now sitting with 30 minutes and you still have 5 or 6 or 7 questions, this is something that you can nearly see. How can I eliminate the options? So then it's minus 0.19. We go straight to the table, negative table, minus 0.19, minus 0.19. Okay, you can see I used this already. So 0.4247, 4247, 4247. Okay, so the area of a the probability that Z is when small or equal to minus 0.19 is equal to 0.4247. And that is that area. Questions? Okay, so again, yes, Len, if you have a question, ask. If you
No,
want to
no,
make a
sorry. No,
comment.
no, I'm okay. This is
Okay,
clear. Yeah, thanks.
Arjun, I just have a question.
yes.
There at the top, you say less than, but I see here with the sign you're saying less or equals to, less than or equals to. Doesn't matter or
See, it does matter. So in your when you look at discrete and binomial and those ones where it is 1, 2, 3, 4, they're less than I would have. It does not include 500. But because normal distribution is a continuous, um, so that is also nearly one of the definitions. Because it's continuous, you include that 100. But if it, and a very nice question. So if this was a discrete probability and your discrete could be, where did we do it? Way back, I think, because I think that is, so if we did something like this here and we said less than, we should not include, but here they would probably not say it in that words. They will probably use those phrases. Um, so, so then very important what they say. Um, so look at, so here they probably would not use those words. Because when we now did this, I was first looking in this set and couldn't find the less than because they normally don't give it straight like that. So in your other ones, they will probably use the words more than at most fewer than. Um, so here they specifically used the less than. And that's why I think this table is so powerful for those instances that that can be confused. But a nice question. I like that because you will definitely see them using the words that is linked to that type of probability that can be answered. I hope that answers your question.
Yes, thank you.
Okay, cool. Okay, so let's go to the next one. Yeah, I have included it at least. Okay, again, education department. The learner's travel time from home to school at one of the remote rural schools is normally distributed still that mean of 114 and a standard deviation of 72. So what is different now? An education consultant has recommended no more than. Let's go. Where's the no more than? Okay, so it's exactly the same as is less than. Okay, so that is what we're going to do. No more than a certain minute of learner's travel time. Okay, so we don't know what it is. If a top department would like to ensure that 15.15% of learners adhere to the recommendation, what is the recommended travel time? I think that was also like one of these that was in your question set. Okay, how would you do that?
Sorry.
Yes.
I think that 15.15% needs to be converted to the probability. So, comma 1515, and then work out the question mark value, the variable.
Okay.
I
So
think.
that is, we're going to convert that into a probability. Let's quickly. So you want to say we go to this and look at something like this.
Is the 15.15 not just comma 1515 said? And then work. Yeah.
Minus 1 comma
Yes, get the Z
oh
out of
03.
it. Yeah.
It's minus 1 comma 03. Let's, so if we go to, so then that one I must take off my options so that I just don't pick it anymore. Okay, so that was 0.1515. Okay, and then we're now looking still for that, but we've got now that value because that is there. So minus 0.03 is equal to, let's say, we do call it x in the 72. Then maths take away the 72. We multiply both sides with 72. So 7, just think of it as a 7. let's quickly 03 times 72. On this side, I get minus 74.16 equal to x minus that. So then you need to get rid of the minus 114. So I plus both sides by 114. So then I nearly get x is equal to 39.84. And then I talk approximately, so that is closest to 40. So approximately 40. Okay, so here they tell us that area. Then we go to, so step one, they tell us that area. Then we go to the table, and we know, if you can look at it, we know it's in the negative side. So we go to the negative table. Negative table I, you look for 0,1515. Okay, there it is, and exactly like that. So it is minus 1.03. So then I know my Z is minus 1,03. I have still got the mean. I have the standard deviation, so I need to calculate the x. So that was then what we solve. So if we put 40 back into that calculation, we will get a z of minus 1,01, which we then, if we needed to get to that, would have gone to the z table. And so if we calculated it, then we would have said, okay, there is the 0,1515. So this is nearly totally swapping how we did the calculations, totally upside down. So definitely totally the opposite way of doing it. Again, something like this, I think it was in your assignments as well, might come up. Remember with the exam, so don't, and I think again it's important that you get 2 questions per study unit. So they will not ask you one like this that you need to work backwards, one like this that you've also had in. They will not ask you 3 difficult questions in a row that takes a lot of time. So again, it's nearly, don't stress too much if there's something like this that you just maybe sometimes don't grasp, because it's not all of the questions is going to be like this. There's 1 or 2 that is going to be like this, that wants to put you off your guard as well. But most of the questions is going to be more straightforward. And it's nearly, if you get something like this and you're like, hell no, it just, remember, you can't go back to your questions. So at least look at some of these things that you have, and then I would take a guess. If I look at where, so if I look at where 0,1, so it's nearly, if that is 114, and you look at the space, then needs to be And that comes back to nearly where was that original question? So if we look at that original question, one standard deviation was nearly 60% already. So I would have done, and this is now totally not what you must do. Um, so if anybody else is listening, this is not, but I would have done something like 114, which was the mean times 0.6. Okay, I would have been totally wrong because I would have guessed when approximately 60 minutes, but I would have nearly just said, let's look at another way to get to it if you are pressed for time. And if you sit with this and you're like, I don't have a faintest idea what to do with it, unfortunately, it is something that in the exam you can't go back to the question. But remember again, you get 13 questions in a paper, you have 60 minutes. Okay, they give you an extra 15 minutes nearly, so say 75 minutes divided by 13. So you get about 5 to 6 minutes per question. So if you feel you're sitting with a question like this and you're already not sure what to do, rather guess I normally say go for option C, but yeah, but don't let one, because this is a difficult question. Let's be honest. Don't one question nearly throw you off guard. The same with this one. So let's minimize this all, that we just can see what we need to do. And this was also in your assignment, was a question like this. Was phrased a bit differently. I think it was on something else, but so let's see, there's EQ scores of learners that is normally distributed with a mean of 80. So let's write that down. Okay, so we know the mean was 80. A standard deviation of 20. If there were 2969 learners with scores higher than 95, how many students took the EQ test? Okay, so you had this in your exam as well, or in your test as well. So they give us the 95. Okay, so let's work out Z 90 minus 95 minus 80 is 15. 15 divided by 20. 15 divided by 20 is 0.75. Okay, so that's 0.75. Okay, so they tell us if there were 2969 learners with scores higher than 95. Okay, so what we need to do is get that probability. Okay, if we have that probability, we know that that probability is the same as the number of learners that has gotten more than that point. Okay, so we go to our probability table. What are we looking for? 0.75. 0.75. See, now if I go 0.75, 0.7734, remember that is going to be 0.7734, so I still need to say 1 minus to get that area. I'll rather go to a negative 1.75, negative 75, and I get 0.2266. Yes, I know that is 0.2266. So I know now that that area of 0.2266 is equal to 2969 students. Okay. So if that area is so many students, how many students are there? So then we look at this whole thing and we need to just say if that small area was 2969 students, how much is 1? So how much is 100% of that? Okay, so okay, I just want to get everybody fine up until this point, or must I go through and just calculate everything and then explain again?
I'm okay so far, sir.
Okay, so
Explain it, sir.
for me to get to the total 100, I would say, oi, where did that now go? So I want to get to the 100 of the students, or 100% of the students. Okay, and the easiest to get to there is to say, well, that 2696 or 2969 represents 0.2266. So if I divide that into that, I will get my full 100% of the students. And then that will give me 13102. Interesting that I say that to that level. If you look at what is in here, so, and that's why I did minimize it. Here they use 91. So again, it was out of a papers. So all that they did is I messed with that one for the different types of papers. So for some of you it would have been 95. For some of you it would be 91. For some of it would be a different. And I think just so that again reiterate the not comparing while you're writing with somebody else. Look at those answers. There was 5903, 1312, 1500, 1580. Those two went there, but very easy now that you say if you tell a friend, oh no, on this one I got B, and you actually had the other one because it was referring to different things. So the rest of the question very similar. If they change all that, or they would change that. Okay. This is, I think it was in your what was it, in your assignment as well. So nearly, if you relook that, and it's interesting, did you guys ever get feedback on your assignments? As in, this might be possible ways to answer or did you just get you had 10 out of 12 or something like that? Did they ever give you actually answers to your assignments?
I haven't really checked, to be honest, huh? I just know the outcome, what you got right and wrong, but I don't know if there's any detailed feedback as to how they got the correct option. I'm not too sure
Okay,
if
so
anybody else
if anybody
has.
has gotten any feedback, please forward. I have some, but I will see if I will share that with you guys as well. Um, the lecturer tried to share some of the outcomes, but it was very difficult to get that out of the system as well. So um, yeah, so I'll see what I can share with you that I have, but please share on your side as well if there was anything shared. Okay, so that was nearly the 50 slide 52 and 53 is the most difficult for me. Because that is nearly not the traditional way of of answering the questions. This one crept in last year, which was a big surprise to the students. So it wasn't there before. So it crept in last year in one of the I think it was in the mock exam. Um, and that's why, please, when you do the mock exam or do the mock exam, um, because that is what what is really nice. That is nearly going to be a reflection of the questions. So please do the mock exam when it is available, because that is going to be, if I let's say probabilities on that is going to be close to 80-90% of how your exam is going to look like. Okay, next one. Random sample size 120 is drawn from a normal distributed population with a mean of 160, standard deviation of 50. Define the standard error. Okay, so also please check these questions, because one nearly always goes into the thing of wanting to calculate the Z, because that's nearly how we been programmed. They just want that. So they just want the standard error, not anything else. So standard error is your standard deviation. Population with a mean standard deviation of 50 divided by the sample size, the square root of the sample size. Okay. They give you all the other things to actually calculate the Z, and I won't be surprised if one of those numbers even give you the Z. But all they want, standard deviation or standard error, so 50 divided by the square root of 120, and your answer is 4,56, which is option B. So again, just read your question, because here they didn't give you X, which is good, but they gave you the the mean. So luckily you would not have been able to to do the Z calculation. Okay. So that is a very easy one. Standard error, just your standard deviation divided by the square root of n. Okay. Okay, this one, now we go into confidence intervals. This table is in your study guide. I did copy it in here because for me, what you normally get is 99. So the 99 confidence interval is the one that we normally refer to. But sorry, 95 is the one that we normally refer to. But they in the study guide they give you 90 and 99 as well. That we normally don't get, but we have numbers for that. They're not going to ask you to estimate the 98% confidence interval or a 96% confidence interval or 91 or 88 or anything like that. It will only be these three. So it will not be something weird that you have not seen. But the reason why they sometimes give you this is because we so easily, and I'm taking myself into this, we very easily use the 1,96 because we nearly programmed, and that's why I nearly went to that from the start. We nearly programmed that we work with a 95. So just be careful in the exam, but it will only be between those three. So it won't be anything else than 99, 95, or 90. Okay, so let's look at what they are asking. A random sample of size 100 results in a sample mean of 100. The population standard deviation is known to be 15. What is the margin of error for estimating the 99% confidence interval of the population mean? Okay, so what they are looking for so they're not saying, and this is now important, they're not saying work out the standard error, they want the margin of error. So that is the margin of error for estimating. Okay, so it's not just standard error, it's the margin of estimating. Okay, so we don't want even to look at the mean. So sample mean of 100 is not important for us at the moment. We just want to work with that. So working with that, 99%, 2,58 times standard deviation, 15 divided by n, that is also 100. So that n is going to be an easy one because it's so 15 divided by the square root of 100. So we're going to get 2.58 times 1.5. We get 3,87. Wait. So obviously here was an issue because both of them are 3,87. In the exam, if you have that, it will be, you just pick any one of the two. It will be afterwards, but also if you see something like that, you let me know. You can even take a pic of that and send it to me, so that we can let the lecturer know. But if something like that happens, they would mark B and E correct, or they will drop the question in totality, because it may have created confusion. So just if something like this happens in the exam, let me know. Let's quickly see if we used 1.96, we would have gotten A. So if we used 1.96, we would have gotten A. If we used that, it would go smaller, so it would not have the impact. Yeah, so if we used the 95%, then option A would have been your answer. Okay, so again, use the table. Don't try to remember this, because it's not needed. So again, after today's session, I'll resend this so that you have in the latest, and I'll resend it until we are done with everything. Yeah, so confidence interval, use this, because it is there for you to use. Okay, so I have included this for you. I hope when it goes into PDF, it is also clear, because I think we did it when we worked through the study units as well. There's on, and let me first write it down. There's on this, if we look at when we look at the, and what do I call it, margin of error of estimating, there's on this 3 things that can influence your margin of error of estimating. And they can ask you in the exam on these 3 things. If you increase, what will happen to your estimation and things like that. So I've written it down here for you, that you know that you have it. So increase in sample size, your confidence, or your confidence interval becomes narrower. A decrease in the sample, it becomes wider. If Z increases, if Z decreases. So here is that information for you. But let's look at this. So the estimated below are 95%. So 95% is 1.96. Calculated using samples 20, 40, and 60, not necessarily in that order they appear here. Which estimate must have been calculated using a sample of 20? Okay, so sample of 20. So here we can have sample of 20, sample of 40, sample of 60. Okay, so as your sample, so that stays the same. That stays the same. So as your sample decreases, your confidence interval becomes wider. And just look look at it. So let's say that was 10, the standard deviation. Let's say it was 10. So if I divide by 60, if I divide by 40, and if I divide by 20. And let's just see what those answers are. So 10 divided by 60, so that would have been something like 1.29. 10 divided by the 40, 1,58. So you see this number the whole time becomes bigger. 10 divided by 20. 2.24. Okay, so what happens is that number becomes bigger. So because this number becomes bigger, if that stays the same, this number becomes bigger. So if you add x plus minus that, and we do it, let's do it. If it was for that, it would be like that. Then it becomes bigger, and when it becomes bigger, your interval. So when you look for answer, look at which one has the biggest interval. And then you know that one would be the sample for the 20. You don't need to know the other information because they only give you 3 options. So one is for 20, one is for 40, one is for 60. So let's look at the size of the intervals. 112.65 minus 87.35. Okay, so that is 25.3. 115.5 minus 84.5. That is 51. 121.91 minus 78.09. That is 43. Okay, so we're looking for the one with the biggest difference between the two. So it's option C. Okay, so in the exam, they can ask you if your confidence interval estimate, if that increases, so they can have the 90, the 95, and the 99. So that's the one that they can use. They can use standard deviation and they can use sample. And then it's just to look at what the impact is on that confidence interval estimate and how that will impact your answer. The one that I am missing here is your standard deviation, so I will include that for you in the slide pack that you can look at that impact as well when you have it. So I'll still send it after the session, but then I will also update with what the impact of that is when you have it. And when you can, because now in the exam you can just see the increase in sample size becomes narrower, so the range is smaller, so you look for the smallest. Decrease in sample size, you just look for the largest. When you have it already, you don't need to now go and look at what the possibility is and then find the answer. Okay, again, a very difficult one. So again, it won't be paired with something like this and something like, say it again, you will probably get one or two of those ones. So again, don't worry that all of them will look like that. Okay, so let's still see if we can at least finish the confidence index. Um, ah, the confidence index. I'm not thinking about work, confidence interval estimates and things like that. Yes, Lynn.
Sorry, John, just to confirm. So whenever we're looking for any of those parameters like the sample size, standard deviation, um, or the Z value, we always
Mm,
look for the interval. So we're always calculating the interval to see whether it's either smaller or larger.
yes,
Okay.
yes,
Yeah.
and see what way you will see here. They didn't give you X. They gave you that, but they didn't give you X, just so that X was probably 100 or something like that.
Mm.
Um, so they don't give you that. So it's nearly that you physically actually don't need to go and calculate it because you can't, because they don't give you that number.
Yeah, exactly.
So,
Okay.
so what they're actually testing here is if you know what happens when those
Mm.
things change.
Mm. Okay.
Um, because it is probably 100 if you go and test it later on. That X is probably 100, but who knows? Um, and the way what how you can test it
Looks like
is
100. Yeah.
there is a way to do it. Um, add that and divide by 2. Add that, divide by 2. Add that and divide by 2, and then you get your mean in any
Yeah.
case.
Yeah.
So that's nearly also man, I haven't even thought about it that way. Um, because your mean must be in the middle. So if you add the two, so if we look at this one, um, it will be interesting to see if one adds those two together. There might even be like one of my students 5 years ago said he's still on the moral support group, the Scully way of doing it. So if you add those to divide by 2, do that as it if you want to test it later on. I'm gonna check it as well. If you do it, add the 2 and divide by 2, if you get the mean, um, will be very interesting to see if that is a way that we can get quicker to the answer. Okay, let's check the Department of Education earlier findings from a. So we've got 150 students. So we're probably going to use, if we get in, we're probably going to be using this. And then we will, oh, sorry. Now, let's see, you can see I'm still at previous work. Okay, we're gonna do this. Rail travel time of 114 minutes. It's interesting. I just want to check that first one. If you say 1 to 6.88, plus 101.12 divided by 2, it gives you 114. Okay, so all of them will probably be like that, but it's interesting. One can check all of them. Okay, so 114 we know is that. You can assume population standard deviation of learners' travel time is 72. So we've got standard deviation 72 divided by 150. 95%. 95% is 1,96. Okay, so this one was just really straightforward. Use the information given. 114 plus minus, so 72 divided by 115, square root of that is equal to 5,8788. So I need to multiply that by 1,96. So 114 plus minus 11.5224. So the top one is 125.52. And if I say 114 minus 11.5224, I will get 102.48 at the bottom. And then that is my answers. Option 2. Okay, so this one, straightforward. They tell us, also they tell us assume population standard deviation. So just take that into account as well. So when we're working with Z, if it was sample standard deviation, we would have needed to go to the T table. So just remember again the things that I just went for 1,96, but remember it needs to be population standard deviation for you to go that route. If it said sample, we needed to use the T distribution. So not luckily in this time, but when that is sample standard deviation, we need to go to the T. This instance, population go to 1,96. Again, not to worry, we have it from one of the previous tables. Okay, so let's nearly make this one. I want to see there's a few more on. Okay, we're not going to finish all of the confidence intervals, but let's see what is in this one. Okay, household survey based on a sample of 50 households. Okay, so for me, I'm just as one goes along, I'm just completing the formula that we will use. I assume it is Z. If it needs to be changed, we change it in that. Rural village transfer average household income. Okay, so we know that the average household income is 3,500. Deviation of 1,000. This is quite interesting. Based on a sample. Okay, so they don't tell us the standard deviation is population standard deviation. They tell us household survey based on a sample. So we're going to work with a T. Sure. Okay. That is quite interesting, but again, so that is how they didn't tell us it's a population standard deviation. So if they don't tell us, we can't assume, and where you can see they're talking about sample. The previous one, see, nowhere did they ever say we're working with a sample. Okay, so yeah, the word sample nearly needs to tell you, and the lights needs to go off, that gonna work with a T and not with a Z. Okay, T table. Okay, so first let's over T, how it works, and N. I don't know if that's the right way of just writing it. So the alpha here is 1 minus 0.99. So T is 1 minus 0.99 divided by 2, and N minus 1 is the degrees of freedom. So what they normally would first say is the degrees of freedom. Degrees of freedom is N minus 1. So we're going to look for a T that is 49. I think I swapped these two numbers around, but don't worry for now. And alpha that is 1 minus 0.99 divided by 2, which is 0.005. Okay, so I hope the T distribution is here. Okay, we need to go to 49. First, let's see 0, okay, so it's the last table that we're going to work with. Again, 49, last 2,68. 2,68. 2,68. So if we worked with 99 and it was from that other table, where was that? 2,69 we used now. We would have used 2,58, so not a big difference. So if we use 2,58, we would probably get one of those answers as well. So let's just 1,000 divided by 50 square root of 50 times 2.68. So it was plus minus 379. And if I now need to, just want to check 3879. So they want more decimals, 0.1 decimal added. So we'll get, if we add it, 3879.01. Okay, so that will be then your correct answer. I just want to check if we used 2.58, if we used the T, if we would have, if there was an option for us as well. Okay, so if we use T, option C would have been the answer. And it's spot on what they, so it would have been 3,500 plus 364.87. So 364.87 would have given us 3864.87. So very easily one can make that mistake and there would be an answer for you. So that would have been the answer if you used a Z. So very important, and it's clear between these two. Here nowhere did they talk about a sample, so we could automatically go to Z. Yeah, a household survey based on a sample. So when I tell you sample, please just check. Then if I don't tell you anything about the standard deviation, we know that is the sample standard deviation. Then we're working with a T. And unfortunately, if we did work with a Z, there would have been an answer as well. Okay, that is it for today. It's been a long 2 hours. You can see there's a few slides left for us. So I'll schedule some time in the week. I'll schedule on Monday or Tuesday. I'll schedule an hour for us. And then we see how far we get with those. If we're not finished yet, I'll schedule another hour for Thursday or Friday for us, so that the 21st, nearly the way is we now 15, that the 22nd is nearly as our session. That please send questions via WhatsApp. But let's in the week finish with this. And then we've got the 22nd and even I can go through some of the assignments and look at one or two of the assignment feedbacks that I got from the lecturer. So that the 22nd is nearly a round up of everything again, just quickly going through one or two things. And then that last week before you write, we can have somewhere a check-in, just to make sure that you guys are okay and you can just ask questions. But I'll schedule now for sometime in the coming week our session, and then if we need another hour session, I'll do that as well. Okay. Any questions, anyone?
Hi, John. Is the mock exam still on for Monday?
Yes.
Okay.
Yes. So the mock exam, and did they say it's open for only one day or for a week? So just check. I think it will be open for more than one day and also more than one attempt as well. It's supposed to be. I'll just confirm that as well, because not everyone can be available on one day while you're writing other stuff as well. So it might be open for a longer period. What happened last year is also that it was left open for the week, for a few days in that week before the exam as well. But I'll just make 100% sure for you guys. Okay, cool. Have a good